Eye of the Storm, Part 5, by Andrew Hall, narrated by Electric Universe Eyes. Large-scale wind structures. The appearance of the landscape makes obvious it is the result of Earth's electric circuitry stimulated by some outside force that caused massive discharges. Discharges occurred between Earth's interior and whatever charged body in space the Earth was responding to. The discharges, however, did not occur as giant sparks and plasma filaments simply jumping from one charged body to another. The discharges were modulated by the active, intervening layers of capacitance in the Earth's crust and atmosphere. Layers of exosphere, thermosphere, mesosphere, stratosphere, troposphere, lithosphere, and asthenosphere. What lies below that is subject to debate. Magnetic fields respond to current and shape filaments in plasma cells beginning in the thermosphere, from 50 to 600 miles above us, where we see the polar aurora. Atmosphere is segregated by layers of pressure, humidity, and temperature. The crust is layered with igneous rock, shale, limestone, and sandstone, aquifers, oil sands, mountains, and oceans. Every layer presents a different dielectric medium to the flow of current. Motion of mobile species results, as charge diffuses unevenly through the layers. When change takes place in the solar system, the Earth enters a transient phase of adjustment to balance its internal circuits. When this happens, both land and atmosphere go into upheaval, creating an atmosphere best represented by Jupiter's. Fractal patterns of motion, heat, and diffusion on Earth's landscape match the cloud patterns of Jupiter to a T. It's because the same actions of current flow and capacitance is taking place on Jupiter now, in the manner Earth experienced in its creation. We can view these patterns at every scale and find they add up to a coherent picture of the physics behind them. Let's now examine some of the best examples, starting large, then focusing down. Mountain arcs. Look at the following patterns of mountain ranges in Siberia, Europe, and North America. Then look at the cloud formations on Jupiter, and you will see similar patterns. In both cases, the pattern is formed by an upwelling flow of winds and a shear zone of turbulence. These are the interface zones between circulating winds, dust-laden, ionized winds flowing at near or above Mach speed. The mountains were swept into these sinuous strands, hardened and fused by ionized matter recombining, and the radiation and pressure from an intense fire in the sky as lightning carpet-bombed the rising piles of charged earth. Jupiter's clouds display the sinuous shape of the shear zones, where a towering cloud top forms like the anvil of a thunderstorm along the upwelling electric winds, flanked by circulations and downdrafts. If you don't believe me, ask NASA. The primary motion of Jupiter's most turbulent winds are up and down, so the cloud tops of the most prominent updrafts display the motion throughout the column, all the way to the planet's surface. The correlation of shapes isn't proof, but is it coincidence? It's not coincidence if it keeps happening. Repeating forms at different scales is proof of a fractal process. The only fractal process we know in this universe which affects every aspect of matter, whether organic or not, is the process of charge diffusion in an electromagnetic field. We can call it different things, chemistry, thermodynamics, or quantum mechanics, but the closer we look, it always gets back to one thing. It's electric. Let's compare in detail. One spade-shaped feature is almost ubiquitous in Jupiter's turbulence, and on Earth's landscape, the quote, boot print. So it should be obvious there are direct correlations between the clouds and winds on Jupiter and landforms on Earth. If you remain a skeptic at this point, at least agree it is not just me saying so. You can see for yourself. The correlation is not only visual similarity, but also the same causation. Vertical high-speed winds, electrically charged and shaped by electromagnetic fields. Proof of the winds of Jupiter are in NASA's data, and proof of the ground effects on Earth are under our feet, and in decades of applied science and supersonic shockwave behavior. Proper interpretation of the data is all that's lacking. Let's return to the Colorado Plateau and surroundings for a big picture look now that large-scale wind features are understood. Pacific Northwest snaking inflows. A correlation between the Colorado Plateau and the Great Red Spot has similarities of such complexity and detail. It seems absolutely surreal. Inflow to the GRS appears in two sinuous lanes of rolling winds that correlate with the mountain ranges in the Pacific Northeast. Kinky Mexico. From the south, hot, dry winds scorched across Mexico and the American Southwest with counterflowing winds. Along the turbulent shear zone between, kinks appear in the Sierra Madre Oriental, where north-flowing jet streams mixed with the south-flowing stream that formed the Sierra Occidental and the Alto Plano in between. The Great Basin Vortex. Inside the multiple cyclone vortex, the Great Basin is formed by rippling waves roaring across the land in a broad thunderstorm, which brought torrents of rain. Jupiter's analogy is the great white shelf of cloud, which is the anvil of the storm that occupies nearly one half of the, quote, eye. This one is quite simple to trace, since it is a single large thunderhead that formed the basin and range dunes transverse to the wind. In the annotated image, they are denoted by the dark blue lines. There is an S-shaped range at the inflection point where the inflow winds bent to the rotating updraft. The blue and violet lines denote the wind direction, exiting right or east at high altitude over Provo, Utah, where it made no mark on the land until it waterfell on the other side of the shear zone that formed the Wasatch Range, spilling a violent downdraft into the Uinta Basin. Another larger downdraft, which I believe would be the forward flank downdraft in a conventional thunderstorm, flows south over the Wasatch Shear Zone and down to form the Mogollon Rim, the southern extension of the Colorado Plateau arcing southeast from, roughly, Kebab rim of the Grand Canyon to the Gila River in New Mexico. The wind-formed rim is intermixed with volcanoes. Curiously, Nevada's mountains display wind-formed tetrahedrons in the opposite direction than expected, given the counterclockwise rotation of the GRS. I drove through Nevada twice to confirm what Google Earth showed because this was the first case where landforms disputed my predictions. The best explanation for this, given everything in context, is that ground-level eddy winds rolled beneath the mesocyclone rotation like roller bearings under a spindle. This was a wet, rotating mesocyclone carrying considerable moisture which precipitated out and evaporated, forming salt basins behind ranges and culminating in the Great Salt Lake and Bonneville Salt Flats. The long linear mountain ranges of the Great Basin are in many cases wind-swept dirt. The triangular faces of shock wave reflections earmark the wind direction. As the rotating jet stream winds turned east, the shear zone expanded into a turbulent zone, where shear winds slipped past the rotation and sped south in an expanding fan that gouged Amargosa, Owens, and Death Valleys before mixing with other winds over the Mojave Desert. Between these deep desert valleys rise narrow mountain chains with a majestic vertical relief of 11,000 feet, the Panamint, Darwin, and Amargosa ranges. These are sastrugi. The valleys were gouged in mountains raised by folds in the wind that laid like curtains across the land. The Sierra Arc was formed by westerly winds that pressed down against this shear zone while being sucked into the giant vortex. The Sierras formed as the westerlies piled airborne dust and sand dredged from the ocean along the edge of the Great Basin's storm rotation. Volcanoes helped anchor the formation. Intense electrical discharge from the shearing winds fused monolithic granite structures. Lightning in this environment was imposing. A plasma intensifies in a shear zone, meaning it both attracts and generates ion content due to the shearing and extreme pressure differentials. Shearing supersonic winds bounced shock waves between them. Shear regions carried the highest current, in jet streams that extended for thousands of miles. Lightning discharge from these plasma streams focused on the piling mountains below the capacity of a 1,000-mile-long thunderstorm being continually fed new energy. The current that dumped in the strike zone didn't simply flash a split second here and there, but arced continuously, diffusing through the land, welding granite from the dust and sand. Here is a different image that displays the wind-blown pattern of the topography. To the west is another shear zone that formed like a wall between this storm and the one that formed the Wind River and Uinta Ranges to the northeast, and the one that formed the Colorado Plateau to the southeast. This is the Wasatch Range, massive windswept dunes pinched between the giant rotating storm systems. The great thunderstorm that rotated above Salt Lake spread an anvil cloud which fed the cyclonic storms over the Colorado Plateau and a region we'll call the Wyoming Vortex. It dropped in a vast downdraft that formed the Uinta Valley. It also spilled into the cyclone over the Colorado Plateau, joining the general rotation of winds sweeping up the Mongolian Rim. The Wyoming Vortex. A simple example of wind mapping uses the Wind River and Uinta mountain ranges. In the following sequence of Google Earth images, the first shows the Wind River and Uinta ranges without annotation. The second is a close-up on Wind River. Next is the same image, annotated to display the triangular buttresses. Last is the image annotated with wind direction showing the jet stream path of ground level winds that created these pressure ridges. The mountain ranges formed as lightning, or red circles, arced to ground and charge diffused across the land in channeled currents, which formed dikes. Dikes are walls of rock formed from the country rock fused together, and often display troughs alongside where material sucked to the current. An example is the Tetons, where Grand Teton itself is a lightning-generated fulgurite surrounded by smaller fulgurites blanketed with wind-driven dunes. The Teton fulgurite extended a dike to the south which collected dust against it, creating a mountain lobe. Wind piled material against them to build a mountain lobe and leave the northern flanks patterned with the sonic shock of the wind. Winds that deflected from horizontal to vertical left ruler-straight ridgelines of triangular buttresses where shock reflections patterned diamond-shaped regions of expansion and compression. You'll notice the wind path points to unusual ovoid features on the land. This is a dome deposited by electric winds pulled into the updraft of a thunderstorm, where the arrow points was an updraft where the jet stream arrived at a coronal loop. The jet stream loops up into a thunderstorm and back down through a cyclone next to it, which forms the odd-looking, almost square feature next to the dome. It is a crater formed by the downflow eye of a cyclonic storm. The thunderstorm and cyclone are opposite legs of a loop the jet stream flows through before it exits to the east. The jet stream wraps over and under itself in 3 dimensions like rope and a knot, alternately forming a dome on the land and then a crater. It is a dome and a crater pair created by a tight coronal loop. The looping coronal currents spun the jet stream across the land, creating the Wind River and Uinta ranges as pressure ridges, like giant sand dunes, and then up through a mesocyclone and down through a downdraft cyclone at near supersonic velocity. The rims of the dome have inward-pointing, shockwave-generated triangular buttresses, and the downburst crater has outward-pointing buttresses that can only be the result of supersonic winds. If you are curious why this dome and crater set in Wyoming forms almost polygonal shapes, you should be. The reason is they are pressed against a shear zone between this storm rotation and the larger multi-vortex rotation over the Colorado Plateau. The Wyoming vortex is the smallest of the 3 primary vortices in the larger multi-vortex storm. Colorado Plateau in the eye of the storm. We looked in the last chapter at the overall morphology of winds in the eye of the GRS and the Colorado Plateau. Let's take an even closer look. The eye is a multiple vortex cyclone which displays a complex system of coronal loops that twist the wind into a crocheted doily pattern. This cyclone is separated from the Wyoming vortex by a shear zone. At this shear zone, like others, mountains formed beneath welling updrafts. In this case, nestled against the powerful updrafts of the San Rafael Swell and surrounding cyclones, it formed in the shape of an oxbow. There are several updraft domes and downdraft craters centered on the Colorado Plateau and Rocky Mountains. The most distinctive is the San Rafael Swell in central Utah. The swell is ringed by the explosively charged, dense region of recombination and magnetic pinch known as the San Rafael Reef, where rows of dragon's teeth, the triangular patterns of rarefaction in hard, fused sandstone, provide evidence of a shock wave at the boundary of the updraft. The reef is the rim of an updraft dome formed beneath an intense coronal loop that raged electrical havoc on the land at the sharp end of the storm. The dome behind is shaped like one lens of an eyeglass, the other lens an inverse copy made by the downdraft of the same loop. Another example of an updraft dome is Monument Valley, Arizona. Its shark's teeth rim is formed by inflow winds expressed in the triangular sandstone layers of Comb Ridge. The interior of the dome is the sputtering remnants of lightning-diffused mesas and pinnacles, preferentially left behind as the landscape around lifted away in the most intense region of electric field in the eye of the storm. The downdraft leg of the Monument Valley updraft lies in the bend of the San Juan River as it passes through the Four Corners region. Annotated to distinguish the features, the same eyeglass shape is evident where this coronal loop connects with Earth, but the shape is skewed to the ambient counterclockwise rotation of the entire storm system. The downdraft lies at 90 degrees to updraft because this is ground zero for the eye of the storm. Note, the San Juan River arcs around the downdraft after it passes through the center of the updraft, just as the tributary of the Green wrapped around the Capitol Reef downdraft center and then shot through the heart of the San Rafael Dome. These are the fractal forms of surface conductive charge diffusion, or arc blast, and the rivers are part of it, which will be discussed in future articles. Nested fractal elements. There are fractal repetitions in the up and down drafts. The most striking example lies smack between the updraft dome and downdraft crater of the San Rafael coronal storm loop. Watch this fractal expression expand in scale. Images are taken from a z-axis in space from a single point on the ground at varying altitudes. The fractal repeats, but the center point of each fractal expression stays in place. It morphs in form with emergent effects, but the fundamental circuit relationship remains solidly displayed. They are the same weather patterns we have today, but of super Olympian scale, as told in countless ancient accounts. We need to start listening to the ancients because they knew things we don't. So let's recap. Weather is produced by plasma actions in an electric field that is coupled to ground currents by capacitance. Cyclones and mesocyclones carry the most violent winds and vertical drafts. In a primordial past, Earth's weather was like Jupiter's, due to an amplified electric field. The primary atmospheric actions that shaped the land were lightning, tornadoes, cyclones, mesocyclones, sputtering discharge, charge diffusion in solid-state matter, and winds stirred by the storms to supersonic jet streams. All these phenomena are electric and fractal. Lightning and tornadic plasma filaments raise fulgamites and fulgurites. They come in many forms and sizes. Sputtering discharge eats land away due to charge diffusion throughout layered sediments. Supersonic winds form standing shock waves that capture dust in a rarefaction zone called the separation bubble. It forms tetrahedron-shaped buttresses behind the interface of the shock wave. And sinuous updrafts form mountain chains in repeating fractal patterns. The next chapter will look at ground currents and the actions and landforms they produce. For more information, please visit thedailyplasma.blog.